All right, take a moment and solve those for x, those two equations for x. X squared equals 36, and then x squared equals negative 25. All right, so for these where you just have an x squared, there's no other x's, we can just use the fact of what's going to undo a square, or what's the opposite of a square? Square root. So here we can just square root both sides, but we do have to remember when we're saying what's the square root of 36, we're saying what times itself is 36. So therefore, what are our answers going to be? You got to get two answers, 6 and negative 6. So plus or minus 6 is our answer here. Because remember, 6 times 6 is 36, but negative 6 times negative 6 is also positive 36. Now, when we look at the second one over here, before we would always say, before about this week or early last week, we'd say you can't do that. There's no number square that gets you negative 25 because you can't take the square root of negative. But now that we know about imaginary numbers, we can say, all right, well, the square root of 25 of negative 25, I can break down as the square root of 25 times the square root of negative 1. We still need that plus or minus in front of it, however, okay, because, again, what number square is going to give us 25? 5 times 5 or negative 5 times negative 5. It's just now we're going to have the I with it. So our answer here would be plus or minus 5I. So we're going to use this, is called the square root property. We're going to use this square root property today to help us solve equations that have just x squares in them. Okay. Yesterday we had x squares with x's, so we had to factor it. But if we have just x squares, we're able to use this square root property. All right, so you can write this down here. It says when you have x squareds with no other x's after that, you can undo to solve. Undo means PEMDAS backwards. And we can say, and use the square root property. So if you look at all three of these problems that are up on the board here, notice how all of them have just x squareds and they don't have any other x's with them. Okay, so that's what we're talking about. This is where we can use our square root property. Yesterday, all the problems we did and all the problems on the homework had x squares with other x's involved. You can't use the square root property for that. That's when you're going to have to factor. All right, so as we're thinking about PEMDAS backwards to try and get these x's by themselves, we have 3x squared minus 21 equals 0. Again, PEMDAS backwards means I undo addition subtraction first. So I'm going to get rid of this minus 21. Do that by adding 21. Okay, there's no other addition subtraction, so as I move backwards on PEMDAS, and now I undo multiplication division. So I'll divide both sides by 3, and I would get x squared equals 7. And so now to undo a square, like we said, we're going to take the square root. 7 is not a perfect square. No perfect square divides into 7. So we don't have to simplify that. We can't simplify that any further, so we're just going to write this as plus or minus the square root of 7. So that really gives us two answers. Our one answer would be negative square root of 7. Our other answer would be positive square root of 7. For the second one, again, we don't see any other x's. Okay, we just see an x squared, so that means we can use the square root property. We're thinking PEMDAS backwards, so we undo addition subtraction. So I'm going to undo the addition of 45 by subtracting 45. We're undoing the multiplication of 5 with division by 5. So we get x squared equals negative 9. And then to undo that, we would take the square root of both sides. And again, we can simplify this now. We would think of it as plus or minus the square root of 9 times the square root of negative 1. And so square root of 9 would be 3, so we'd have plus or minus 3, square root of negative 1 is I. And again, as this solution set, that's really two answers, negative 3i and then positive 3i. And then our last one, it just has the parentheses squared. There's no other x's outside of that. So some of you may want to like write it twice and multiply it out. That's how we did it yesterday. You could do that, but then you have to factor. But notice there's no other x's outside of this. If we just have an x inside and it's being squared, there's no other x's outside of it, we can use this undoing or square root property to get this by itself. Okay. So as we're thinking about PEMDAS backwards, is there anything added or subtracted we can get to right away for this problem, letter C? We see plus 5, but can we get into that right now? No. So I can't undo any addition subtraction currently. Is there any multiplication division I can undo? Nope. So now I look to undo my exponent. So the way I undo a square is with a square root. So I'm going to right away take the square root. The reason I'm square rooting that is because what happens when you square root something that's being squared? Cancels out. So we are left with just what's underneath here, x plus 5. And it would still be equal to plus or minus the square root of 11. If I could simplify square root of 11, I'd want to do that there. But is there any perfect square that goes into 11? Nope. And now I still need to get the x by itself. So I'm going to subtract 5 from both sides. So what that means is I get two answers. I'm getting negative 5 plus the square root of 11. And then I'm getting a second answer that would be negative 5 minus the square root of 11. And we can just leave our answers like that. So in our solution set, we have negative 5 minus square root of 11, positive 5, square root of 11. So again, that only works when we have x squared with no other x's.